Thanks, Carol. That's brilliant. Welcome to the presentation on BSc Engineering. We don't want to try and hard sell you on anything. We just want to tell you the essentials of the BSc and how we run it and what you should look for, whether it's through us or through another university or college. There will be some people with a problem with audio because you may not be using Chrome, Firefox, or Opera. If you're not using those, you've got a strong probability of problem, or maybe your speaker doesn't work. So if you do want to text, please shout. Just text in the box and I'll respond, or Carol will respond very quickly. I'm going to try and keep this short to 25 minutes. We'll give you plenty of extra information, so just hang in there. I don't want to just talk for an hour. I just want to keep it reasonably short, so I've got my little clock next to me. I'm actually on the corner of the Indian and Southern Oceans, if you can visualize where it is. So I'm the dean, and we've put together this program over the last 5-6 years. So that's basically my experience. I've been basically working as an engineer, building oil and gas platforms, mining plant, power stations. So I've got a very practical bias to the whole course. I'm obviously just one of the players here. If you can't hear, you obviously won't hear me telling you this, but we will be giving recordings to anyone. I just also want to say, please, if something happens and you drop out or you lose audio, just log back in. The internet does have potential problems where you are. You may be on some remote site, and of course, you may not be hearing. Or indeed, I'm on a remote outcrop here, and I may also drop out, but I'll log back in. So that's all part of the joy of the internet, and that's the way it goes. So first of all, we've been putting together courses for some time, for 25 years actually, and in the last 6-7 years, we've been providing diplomas, master degrees, and now we're putting together a BSc degree. There's a full brochure detail on it. So all I want to do in this little presentation is give you some background. So really what we're going to do is talk about the benefits of a BSc engineering, the structure. I want to use this word articulation to explain what that is. I want to talk about 4-year versus 3-year program. This is a 3-year BSc. I'll explain why it is a 3-year rather than a 4-year. And then the master degree is an important coupling to it. I also really want to talk about one of my interest areas, which is remote and virtual labs. And then finally, I want to talk about accreditation, and then we will finish off with question and answer. So that's basically where we're going from. So really, if you can look at this diagram here, this should give you a view of where we're going in this presentation. Can you all see the diagram here? It should be online routes to engineering career success. Can you all see that? If you can see it, just do a little, put your little hand up, or put a little friendly thing. Excellent. Thank you very much, guys. Now, what we're trying to show in that diagram, and Shane, bless her socks, she's tuned in here. She worked on it to try and make it a bit easier. What you'll see on the left is the sort of place where you come from. So let me just do a little circle around there. I'll just do a little, excuse me a moment. I'm just going to put a little thing here. Trade certificate you could come from. In other words, you're a tradie. And then, of course, you, or artisan, as they refer to in Africa. You've got a certificate, which is basically at the level of a school leavers, or I would say above. And then you could have an advanced diploma. And our guys, starting in September, basically have done a EIT advanced diploma, which is 18 months. And as Shane says, you can see a bigger version of this diagram on the website, but you can enlarge the screen, by the way. If you look at the right-hand corner, you'll see a little thing which says switch whiteboard to full screen mode. You can actually widen the screen so you can see a bigger thing. So you'll see that. Then you take your 18-month diploma. Sometimes some guys take longer than that, and then you go on to the BSc. So this is the path that we are following in September, and we're running it in different disciplines. So you have electrical, industrial automation, Mechanical and civil will be starting in January. So we've got 4 disciplines. You may also, in January, come along this route here, which means you don't have an advanced diploma, but you've got some other basic trade certificate. Also, bear in mind, the advanced diploma we've been talking about is the EIT one, like an Advanced Diploma of Electrical Engineering, but you could have an HND or an HNC or a myriad of other qualifications. So just call us for more details there. Now, the important point to make is that when you finish an advanced diploma, you basically practice as a technician, as you can see there. When you finish the BSc Engineering, it's a 3-year program, you will be able to work as a technologist, or in the UK, they refer to the term incorporated engineer. And often you're basically working as an engineer. If you want to get full professional status, you would then continue for another 2 years, but you would do this online as well, which is a Master of Engineering. And that is a 2-year program. And then by the time you finish that, you would be well above any person doing a 4-year program. So that's the thrust of this whole approach. The Master of Engineering is particularly practical, and obviously the BSc Engineering is practical as well, but they do articulate, they do fit with each other. So that diagram is what's underpinning my little presentation here. The benefits for you in doing the BSc obviously is if you've got a certificate or a diploma, the BSc basically allows you to practice as a technologist or an incorporated engineer. Benefits for us in providing this course is obviously we're passionate about engineering education. And just to run through some of the benefits, I'm not going to go through them all because we don't have enough time, but basically the courses that we are providing are industry focused. We're not trying to pussyfoot around fast Fourier transforms or advanced digital signal processing. We're focusing on making the BSc the best in a job-focused outcome without sacrificing the quality. In fact, we believe industry-oriented makes it a more challenging program to offer, but we believe you will benefit in the job. The instructors, without any hesitation, are all 10, 20-year experienced. They're all working in industry. They have the hard yards. They're not a theoretical PhD. Please forgive me, I've got a PhD, but they're not PhD and a bit lost for theory. They actually are focusing on industry. There are places for PhDs, and certainly if you're doing R&D, doing some leading edge R&D, you would need a PhD, or your PhD would be useful. But when you're working in engineering, you need hard-headed, experienced instructors. Thanks, Casey. I'm sorry about the problems we had with audio. That's one of our biggest problems, anyone that logs in. Truly online, our sessions are online. We have live sessions. We don't give you videos. You'll find a lot of cheap courses will give you videos and say, there's your course. That's not a course. A course is a live session with a highly experienced instructor, and you're interacting with them like we're doing now. Obviously, hopefully a bit more interaction than we're doing now. And remote labs, and which means you can work on your oil rig, on the mine site, anywhere. The other next point is high quality accreditation from the Australian government. We've gone through believe it or not, a 5-year accreditation process. It's very meticulous, and we're going through accreditation processes with Engineers Australia, which gives worldwide recognition, and we're doing accreditation with other bodies. Later in the year, we're doing the UK as well. So that's obviously something which is ongoing accreditation. It's very important to give some credibility because there are so many diploma mills which are rip-off places. Global recognition for these programs. ISA is one of the largest societies in the world with industrial automation. There's a continuous pathway from the trade, which you obviously see from that diagram. And obviously the other idea is that we believe we've got a reasonably good reputation, an excellent reputation. But again, that's something you have to judge. I can't convince you on that. We've been around for 25 years and trained 500,000 people on various short courses. And the other issues are, for example, supporting library 100% online. Fortunately, we've reached the point now where you can get libraries and resources online 5 years ago, you couldn't, and we can get them affordably and make them available, whereas in the past you couldn't. So we're very lucky to have that position. And then finally, one of the biggest concerns you have when you engage in these programs is, will I drop out and will I waste my money? Well, that's a very real concern. If you look at the attrition rates, I was talking to some of my colleagues in the office this morning who did the traditional engineering degree programs, and the attrition rates of 80% are quite often common at a university. Our attrition rates for our diplomas are about 20 to 30%, and most of the time it's due to financial issues. We believe we can get you through a rigorous program with our dedicated learning coordinators, and they are a secret weapon. You would have come across them at the advanced diplomas. They work with you because we want to get you through the courses. We get measured on success. But in saying that, we do not sort of let you just tick boxes and pass the course. The course is challenging. So if you're not prepared to put in 10 to 15 hours a week, study and online work, you probably will find it very difficult. You'll take a lot longer than the time we predict. Just want to throw open the floor to Shane and Carol at this point, because everyone's been listening to my voice. You want to just say a few words, Shane?
Hi, thanks, Steve. I have a little bit of a noise in the background here, so excuse me. I've got my kids floating around, so I might keep my talking to a minimum, if that's okay.
Thanks, Shana. I just wanted to put you on the spot there. Carol, if you want to also say something, just interrupt or just chat there. Thanks very much. Shana is, I've pulled her out from, it's well past work time, but I've pulled her in to help. She's one of the architects of some of these programs. In fact, she designed the structure, which is what I want to talk about now. Now, the structure of the program is an interesting one. It's fully detailed in the brochure, but basically what we try and do is we have interaction. Good. Thanks, Hendrik van Heerden. I'm sorry that you're going through all this nonsense with the audio. It is an ongoing nightmare for all of us. And if you do drop out, just log back in. The structure of the course, it's very easy to explain, but you actually find the brilliance when you're actually doing the course. Essentially, what we do is we force you to attend the sessions every week. Or if you can't attend them because you're flying to an oil rig, we say you need to watch the recording and report back to us. So first of all, we need ongoing interaction every week. We believe if we lose contact, like the internet, we lose you as a student. So we really need, the whole structure is designed around keeping contact with sessions we typically are running, if you look at the program, you'll be running on the part-time intensive, you're running about, there's 2 units effectively every week that you're attending. So there's basically lecture sessions at your convenience. We try and structure it so it's through the different time zones, and often we repeat the lectures 3 times. We have them run 3 times through the day because of the different time zones: Australia, Asia, Africa, Europe, and then of course North America. We have you attend those sessions, and then you also expect you to do the online labs as well. Now, labs are not Mickey Mouse, click a box or play with a bit of software. It's actually doing real test and measurement, trying to ensure that you get some unpredictability to the exercises you do so that you actually do learn something. And above all, and this is one of the most important things, we believe that with the part-time intensive, we need to keep your workload to a maximum of 15 hours per week. 15 hours per week is the magic number. That means your contact time, which is 3 or 4 hours a week, plus self-study, which is about another 5 to 10 hours, depending on how good you are. So if you're very clever and you are completely on top of the subject and you're very familiar with it, you're probably only going to take 3 or 4 hours. If you're very, dare I say, thick, but I probably shouldn't use that word because I'm probably thick. But if you're very, the material is very challenging and you're working really hard and you're just trying to get into the study again, you'll probably take about 15 hours, we believe. So really, if you look in the box, the box that Shana said here, really, you should be familiar with the structure. But the important thing about the structure is we're trying to keep contact. So we want to keep more contact with you guys on a weekly basis than you do in a college or university. And that's the brilliance of this online methodology. So very important with that. And the reason why we insist on contact is because we can believe we can minimize the attrition rate, the dropout rate. So there's a few suggestions here about learning technologies. I'm not going to worry too much about that. You'll get all these slides, by the way. Now, as far as scheduling is concerned, or scheduling, we're opening in September, in January, and July. So we're basically starting a September one because we've waited 3 years to get this program. So we've got a whole group of students will start, and then they'll go over the 3 years, 3.5 years of the program. Bruno Satchoff, please try exiting and logging in. No audio. Yep. Okay. Now, articulation from other qualifications is obviously an issue. There's a program here, and I'm not going to go through every detail here, but let me just run through this here. If you are looking at the program, you're going to wonder what sort of recognition you get. Well, if you're doing if you've done the EIT advanced diplomas, it's very structured for the advanced diploma of electrical engineering and the industrial automation, and obviously the civil engineering one and the mechanical ones, very straightforward. And you'll get credit typically of about of a 3-year engineering degree, you're getting credit of about a year and a little bit more than a year. Now, everyone says, well, okay, I've got this program here that you've got. It's a 3-year program. Why are you taking longer than 3 years to offer it? Well, the reason is simply because it is a part-time program. It's part-time intensive. And that's one of the reasons why the program will run longer. One of the challenges with us, with running this program, is that we don't want to overload you, because we know if we overload you, you're going to drop out. But by the same token, we've got to cover the material. And that's why we end up with, if you did it part-time, you would take 6 years. We believe, following our processes, you'll take 3.5 to 4 years on top of your advanced diploma. So really, that's the rationale behind it. But you will get credit if you've done other units, or if you've got experience, we can give you credit as well. You obviously need to talk to us about that, and we'll give you what we call RPL. So typically, there's a few case studies here. I'm not going to, again, go through them all. But basically, for the example here, BSc Industrial Automation Engineering, the credits are already defined, so you'll end up with 3.5 years part-time articulated entry. And as I said, it would normally be a 6-year part-time program. So 3.5 years is a good saving in terms of the total time, plus obviously the 18 months that you've done with your advanced diploma. And we give predetermined credits. And obviously you would find the course a lot easier because you would have seen the methodologies we followed if you've done one of our advanced diplomas. One of the challenges we do have is that because we've got to make sure that this course is going to be internationally acceptable, we do have to put some mathematics into the course, and the mathematics has to be at an acceptable level. So you'll find what we've done is the first mathematics module that you do, which is generally where students tend to drop out, is the maths, because they don't see the reason for it. The first level mathematics is basically at the level of school leaver and a little bit more. So we try and bridge your mathematics in the first mathematics module. But after that, you go into a higher level unit of mathematics. And of course, we then are pushing the boundaries. But again, we're doing it in a very systematic, trying to apply it to engineering and giving you massive support. And we believe with that, you can get through mathematics. And mathematics is probably one of the challenging subjects on all these engineering degrees. Carol, can you just confirm that you can all hear me, that I haven't wandered off into the wilderness? There's a few other examples here. BSc Mechanical Engineering, again, 4 years part-time because we can't give you credit. Thanks, Carol, that's brilliant. Thanks, Shana. I'm just always petrified that I've disappeared off into the wilderness with my thing. So just to talk about I'm just going to go to the diagram here. We've got a few examples here of students who don't have courses that are equivalent to our advanced diploma. They may have an HND, for example. So, for example, an HND in mechanical engineering, we will give you credit. We'll give you credit, obviously, if you've got industry experience. That's very easy to do because we can ascertain your industry experience. And then the units, we've got to make sure that they do match up with our units that we've defined, because we get checked by the Australian government and we get regularly audited. So we've got to make sure we are squeaky clean with recognition. We're not a shonky college just saying we give credit to anything, because the only thing that matters is your credit card. We're not in that business. I repeat, not in that business. There's a few examples here of students. So again, to come back to this diagram, and as Shana says, please, oh, good. Thanks, Carol. Thanks for motivating me like that. This diagram is, as I say, the epitome of what we're trying to offer. So please, again, see the vision. You start here with your trade certificate. You've moved up and done your advanced diploma with EIT, or you've done an HND. You then go to your BSc, which is typically 3.5 to 4 years, and you then leave as a technologist or incorporated engineer. For most purposes, you are an engineer. It is a 3-year full-time program, as I said with us. If you don't follow this route, you will basically be spending about 5 to 6 years in total. But the good thing about the way we've done it here is that if you ever have to stop, or you have something happening to your life, and there's all sorts of problems that happen in life, money, your wife runs off, you lose your job, you have health issues. I mean, we all are confronted with daily problems. At least you've got some credit. You've got an advanced diploma, for example, and you've got something to show for it. So that's why we try and make this program what we call step on, step off. And then finally, if you really want to go right to the top and become a professional engineer at the pinnacle of the profession, no further to go, you do the master's. But again, the Master of Engineering you do online while you're working. And again, it's a part-time intensive. And again, very vocational, very focused on industry. There are other routes here for guys that don't have an advanced diploma. They've just got a trade certificate. You know, they've basically finished their trade, which is above a matric or a school leavers, and then they will do the full BSc program. So it'll be a bit longer. But again, we will make sure that you do it in the shortest time possible for a 3-year full-time program. And then finally, late next year, we got high school graduates coming straight in who don't have any industry experience, and they are at a major disadvantage. So they do a full BSc program, and we actually have requirements there for additional labs. Some of them don't even know what a multimeter is. So this leads us on to the subject here of remote and virtual labs. And at this point, I just want to ask, are there any questions from anyone? If you can text in the box. If there's no questions, I'll continue. But please, as I said, I don't want to go on longer than half the hour, and there'll be questions at the end. But please, are there any questions? No, nothing. All good. Thanks. No, all good at the moment. Thank you very much, guys. Wait till the end. Okay, good. Okay. Now, you may ask, okay, if you would like to go all the way to the master's, cost of course. Yep. Okay, we'll give you the costs. What's the accreditation for this course at the moment? Okay, I'll come to the accreditation in a moment. I'll come back to that because that is really important. The question is, how do we run these courses? And I'll come back to those questions. Thank you very much in the text boxes. That's really fantastic. Engineering Australia's accreditation. I will come to that. Please remind me if I don't answer that question, I'll zap me again. Carol will keep me honest there. What we're doing is we're using remote and virtual labs, which enables us to log into labs which have real equipment connected to them. And that's something we've been working on with some mixed success. I must tell you now that the most important thing about a remote lab is that it is unpredictable. In other words, it's like real world stuff. And as you know, when you're working on a real world site, whether it's Sasselberg or Telfer or Mount Newman, you work with equipment which is unpredictable. And you, as the technologist, engineer, have to confront that and deal with and troubleshoot. And that's why you are paid for what you're doing. So that's the trick with these labs, is we have to try and make them as unpredictable and as useful and as practical as possible. So we put a lot of effort into this. So we have real equipment, and you're logging into real equipment to do real tests. But by the same token, we expect you to have industry experience. So you would have worked with a multimeter, and you don't need to go through all the nonsense of refamiliarizing yourself in some silly lab testing resistors and stuff like that, because we believe if you've got the industry experience, you would have done most of that already. So we give you credit for that. This is in contrast to someone who's 17 years old, has come out of a high school and goes and does their BSc engineering. They often don't even know what a multimeter is, and probably don't even know some of the basics of mechanical engineering, working with a lathe or even with a drill. They're often very naive. So that they are in a different category, and we have to provide them with supporting labs with real equipment. But if you've already been working in industry, we believe we can short circuit a lot of that. So we've got a very careful way of auditing your practical knowledge. There's a question there. On the DI, there's no instructor for lab sessions. I found this a lack since many remote labs aren't straightforward. Yep. No, that's a very valid question, and I'll take that on board. Yes, I'll take that on board. We have got a full-time guy now who actually is in charge of the labs, James Theodosius, who's actually a practicing engineer. He's graduated with an engineering degree, and he's actually be supporting the labs together with Emil, and who's got a master's in physics, and we've also got Kim, our IT guy. So we will do that. But I hear what you're saying. You want more support, and I'll certainly take it on board. Shauna, do you mind just making a note of that and passing it on to Steve? Is EIT improving the overall access quality to remote labs? I know you said they simulate real-life scenarios. In universities, all labs are instructor-led, but there's been an issue with a lot of students. Yep, no, I understand that. What we've done is we've widened the broadband access to the labs to try and speed up the access so they're quicker. And we're also putting the simulations on a server, so you don't actually go into onto a physical campus. So there should be a far quicker access time. And if there isn't, let us know, and we'll certainly look into it. But as far as instructor-led labs, I understand what you're saying. We will actually look at that. I'll put that point together. We've got, as I say, a full-time lab coordinator, James T. Theodosius, and we'll make sure that he's actually around for the labs to give you the support. But that's a very valid point. Yep, absolutely. Thank you for being honest and frank about your unhappiness there. It's a good point. To come to the point of accreditation, this is a very thorny issue. Now, the most important thing for you as a would-be student is to know about the 3 accords: a Dublin, a Sydney, and a Washington Accord. Now, these are agreements between probably about 15 to 20 engineering societies around the world, and they're probably the broadest form of accreditation you can get. The Dublin Accord relates to advanced diplomas. In other words, if you get a qualification under the Dublin Accord, it means basically you've got an advanced diploma and you can work as a technician, which is probably not as important as the Washington Accord, but it still gives you a warm, fuzzy feeling that the qualification you've got has got some broad acceptance. The Sydney Accord is for 3-year programs, such as these BScs, and again, that allows you to practice as a technologist or an incorporated engineer, and probably aligns with most of Europe. In Europe, most of the qualifications are 3-year degrees. And then the Washington Accord is for 4-year programs and master degrees, and that enables you to practice as a professional engineer, and that's probably the pinnacle. So that's the overriding principle of accreditation. Now, as far as we are concerned, we've got a few of our diplomas accredited under the Dublin Accord, which means that Engineers Australia approve it, and then as soon as they approve it and they sign off on it, it immediately gets approved on a global basis, which helps you if you're in Canada or the Bahamas or Europe, that you've got some credibility. we're working on the Sydney Accord, so we hopefully will have that through in the next 3 to 6 months. But there's a possibility we never get approved under the Sydney Accord. I'll be honest with you. But I believe that we've got a good chance of going through. We've got all our programs, the people that have been on the programs have assessed them, all Engineers Australia members. So if they don't approve it, well, one would be very surprised. But unfortunately, nothing in life is guaranteed. So I will not lie to you and say we are approved under the Sydney Accord. We're working on it, and we believe we should get accreditation, or what we call provisional accreditation, which then leads to full accreditation in the next 3 to 6 months. And then the Washington Accord, funnily enough, we'll probably get before the Sydney Accord. I know you find that a bit funny, but we've got one of our master degrees going through accreditation process at the moment, and there's a few issues which we've now dealt with, which means our Master Industrial Automation probably will be approved as a provisional. But again, there's a possibility it doesn't. I can't tell you for sure, but that's far more advanced than our Sydney Accord. TEXA are the overriding guys in Australia who accredit these programs. That's the Australian government. And the Australian government goes through a rigorous process. I know it sounds repetitive because they do it and then Engineers Australia do it, but TEXA do it. So that gives a warm fuzzy that you're approved under the Australian government. And the Australian government has accords with the UK, Memorandum of Understanding, and they're well accepted in North America and obviously Africa. So you've got industry recognition of that. Then in addition, we've got industry recognition of one of the largest industrial automation societies in the world, the ISA, International Society of Automation. And then we've got accreditation with other people, which are listed there. So that's the accreditation thing. It's an ongoing thing. I can guarantee you now, for one thing, if you don't have accreditation, national accreditation, and there are engineering colleges without national accreditation, avoid the program like the plague, because it'll be worthless. So you do need national accreditation, and then preferably you need international accreditation. And it is a moving feast. There are programs that have been approved in the past and are not approved anymore. But very important for quality that it has national approvals in place and not by some flim-flam island in the middle of the Pacific. Just to briefly talk about strategies in the future, I'm just going to come back to some questions and answers here. But just, again, I just want to go back to this diagram here. This gives you this diagram here. Sorry. This diagram here gives you the flavor of what we're trying to achieve with these programs. As I said, if you look at the top one there, I'll just use a different color just to make it a bit more interesting. Let me use green. Green is obviously the color, although I think it's bad luck in Africa. Green is the one here. Now, that's the one we're talking about at the moment that we having entry in September. We've got probably about 20 people already in the last week or two that have applied, actually, which is amazing, that have put their application in. The reason why we have it that way, and again, I emphasize, I'm being repetitive here, and I know Shana and Carol probably cringe when you hear me saying this again, but the idea is that you start with an advanced diploma, you get that under your belt, then you move on to the BSc, which takes you 3.5 to 4 years. And as I say, with our learning coordinators and a high quality approach, we believe we can get you through without doing the exams for you, but you actually doing the work. And we believe at the end of it, you'll become a highly effective and specialized technologist, especially with your practical background. And then if you want to go further, you've got some funds, you want to go further, you do the Master of Engineering next. And that means that you're at the pinnacle of your profession. And Master of Engineering is what it means, master. You are at the top, and it's not learning some flim-flam, let's say, digital signal processing techniques and doing some lovely Laplace transforms. It's actually hard-hitting, useful, practical stuff which you apply to your job. And I believe those programs will be highly recognized in the future. There are some concerns which you guys have mentioned, and certainly we're taking on board with the labs. We've got concerns about needing more support. Thank you very much for those comments. We'll certainly look at that. As I say, we have appointed a full-time guy 6 weeks ago. Now, I've got a few questions there, which I'll come to in a tick. The important thing at the top, the green one, is that you've got some practical experience of 3 years or more, and that's how you can get through us recognizing your practical experience, which we can't do with a high school graduate at the bottom. So that's the difference there. So let's just look at some of the questions here, which are a little bit overwhelming. Let me just go back to them. First question is, why 3.5 or 4 years? Okay, I'll just recap that. Basically, the 3-year degree is a 3-year degree full-time. Part-time, it's 6 years. We have given credit for the advanced diploma in the BSc, and that we've had to calculate that against the BSc. We've had a separate committee sit down and say, what do you require in a BSc engineering, electrical, whatever? A bunch of professionals sat down and said, what would they ideally like? And that's how it's been constructed. We then looked at our advanced diplomas and saw what we could give credit for, and that's why the industrial automation one leads very closely in. It's very closely aligned with the BSc, the advanced diploma, and that's why you get 3.5 years. The advanced diploma of electrical engineering, not as well aligned. So there are modules there which are we give credit for, but perhaps not as many as the industrial automation one. That's the main reason. Okay, so that's why the times change. And also you may find that if you've got an unusual qualification, or you may have done some study in other areas in addition to your advanced diploma, which may enable you to get credit in the BSc to cut your costs down and gain credit. You need to talk to us about what you've got and provide evidence, and then we'll look at it, and you may have your time cut down further. But we're not running a diploma where we just check off the boxes. You actually have to do the work. Okay, so let me just get to the next question. There's quite a few here. I'll try and answer what I can. Just hang on, let me just go to the next one. Geez.
Hi, Steve. Just to interrupt there while you're considering the questions. I've had quite a few emails already from people regarding fees and durations. So I encourage you all to contact me directly with your current or previous courses. And what you're interested in, because the duration, the amount of credit, and therefore the cost is all sort of on a case-by-case basis. So it's pretty much quite a tailored course in that sense. So we can certainly ask for someone to call you and talk you through exactly what your individual arrangement would be.
Thanks so much, Shane, for jumping in there. Yeah, absolutely. As Shane says, we are customizing these courses to you, which is unusual, I might add. We are customizing these courses to you in the sense that you provide us with evidence, and we can give you some recognition of your qualifications. We need to look at that. But as I say, the simplest approach is you've done the advanced diploma of electrical engineering or advanced diploma of industrial automation, and we can give you a defined program. It's all clearly defined. But if you've done some other courses, then we need to look at what's going on. And we can't tell you randomly what the situation is. We need to look at what you've done. We have to obviously survive an audit, and we have to make sure we do everything absolutely right. So let me just run through some of the other questions here. 3.5, 4 years, inverted. Yep. Is it assignment-based like in the advanced diploma, or do you do exams? Yeah, that's a good question. What we've got is there are assignments, but there are also at critical points of the course on some of the units, you will actually do a proctored, which means an online exam, but it's not intrusive. You do it, runs in the web, and it's actually looks at you as you do your test. So basically it runs for 3 hours or 2 hours, as long as the assignment is. So there'll be certain critical points where you'll have to prepare and write an assignment on your own because we have to make sure we can demonstrate integrity in the program. So just doing assignments, you could get your auntie or uncle to do them all for you over 3.5 years, which would be rather impossible, but I suppose it's always possible. So we do have these, and it's software which runs on your computer, developed by us, I might add, and it will give us a risk rating. So if we hear your colleague giving you assistance, hello, just fill this in, do that, do this, then we know there's a problem with your exam, and then of course that with that particular assessment. So there are exams, but it's by and large mainly project assignment work. The BSc is high risk. I've just had a pointer that I'm running out of time, so I'll just quickly answer this. There's so many lovely questions here. I just have to answer them as many as I can. I've got here JBT Junior Livecom, which is why I've asked Kevin to contact you. Okay, yep, okay. Kevin's providing that, sorted out. Certainly a score is not achieved. What will happen to the qualification in Australia where the course is not accredited? That's a very good question, something which I love to answer. Basically, if you are in the world, they're probably, if I may be brutal, they're probably 3 or 4 qualification systems you need to look at. American, US, ABET, which is the American Board of Engineering and Technology. That's the engineering there. There's the UK, there's Australia, and probably New Zealand to a lesser extent. And then there's a sort of whole lot of like Singapore, China, et cetera, But basically, if you are in the UK and you've got a qualification from one of the top 3 or 4, you're probably going to be fine. And the same in the States or Australia. If you are in Africa and you've got a qualification from Australia, you're probably going to be fine. Australia, UK, or the States, you're probably going to be fine as far as working with an Australian qualification. If you have should we say, a overseas qualification and you're looking for work in New York and your qualifications overseas, you'll probably find it's difficult because people say, well, it's overseas. I don't really know that. I want a local qualification. So it's going to depend on your experience as well. And that's one of the most important things to mention as well. Experience and a qualification is the route to a job. A qualification on its own is not easy to get a job with on its own. And that's one of the challenges graduates have today that often don't have the experience. You guys have a lot of experience. You have contacts, and you have, with a BSc, you have an opportunity to get a job a lot easier than a poor guy that's come straight out of school, doesn't know what a multimeter is, and is trying to get a job. Do you know which level the BSc will have on the SA NQF? That's a good question. The South African qualifications framework, it will be, I'm just trying to think. It's a 3-year bachelor degree. That's the level it'll fall under in the South African national qualifications framework. So if you look at bachelor degree, it'll be there. The master degree will be above that. It's not an honors degree, which is a 4-year engineering degree. Next question. I do want a BSc, but no accreditation means spending time and money. Yep, absolutely. These are all accredited under the Australian government. They may be accredited by Engineers Australia. We hope they are, but I'm not going to lie to you and say they are. They're not. So we are going through the accreditation process, and I'm optimistic that we'll get through. But believe me, a national qualification, national accreditation is worth far more than engineering and Engineers Australia qualification. But we need both. So that's what obviously we're working for. Why do you charge different fees based on the student country or origin since the program is online? That's a very good question. It's a very thorny one, and it's a very awkward one. But certainly what we've done is we've had to adjust our fees based on the country you're in. Because if you're in Africa, in Kenya, you're probably earning considerably less than someone in Australia. It is a very awkward problem for us because we believe our highest fees, are actually very similar to the local university. But obviously, we can't charge first world fees in a third world country, and that's why we've tried to make it affordable. It is very hard for us and to do that, but we believe we have some social responsibility as well. So it's not just about trying to make a buck. And as far as the profitability of these programs are concerned, they're not very high. It's very hard to make them work. But we believe if we get sufficient students on the courses, we can get make it an economic proposition. In other words, make it worthwhile. But I can assure you, running engineering degree colleges is not an easy road to riches. So we're trying to make it affordable. We do have a social conscience. But again, you have to judge that by yourself. That's just me talking. Let me just go through. I'm going to have to call it quits very soon because I'm going to ask Carol and Shana, do you do the BSc and Karen? Okay, here's a good question. Okay, next one here. Aside, other schools in Australia like USQ and CDU mandate residential sessions. They advise students there is a requirement engineers Australia should be exempt or substituted. Please explain. Well, that's a very good question. We believe that's nonsense. And we've actually had our advanced diplomas exempted from residential sessions. We believe we'll be able to do the same for the BSc. But in saying that, the proviso is that you actually have got practical experience. So if you've got no practical experience, that you will certainly have to do residential sessions and you'll have to do the labs. We believe that's all part of the application. And why do I think we've got a high chance of success of accreditation with Engineers Australia with no requirements for residential? Basically, Engineers Australia are part of a group of countries, including America, UK, South Africa, Singapore, who are accrediting these programs. In the States, they've already announced 4-year programs without any requirement for residential sessions, and those have to be acceptable to Engineers Australia because they are accredited under the Washington Accord. Because of that, we believe that Engineers Australia will look favorably on this. But again, I'm just saying the probability is they will, they may not. They may say, look, you're going to have to spend 2 weeks or whatever on site. We don't know for sure, but we believe it's been accredited by the Australian government. We believe that will get us through, but I can't guarantee you. But we believe the precedent has already been set, so it's likely that requirement will fall away. But in saying that, there's no ways on God's green earth that you will let a student do a 3 or 4 year engineering degree if they have not got any practical experience and have no ability to work with real equipment. That would be suicidal for a job for that student. So we would obviously make sure that the students do have practical experience in the area of the course they're doing. So, okay, next question. What is the plan? Okay, here we are. Okay, hang on. I'm just trying to ask the next question here. There's a lot of very interesting questions here. I'm just going to ask Shana to jump in here. Shana, are you getting tired of listening to me?
Steve, no, I'm not getting tired of listening to you. Just answering, getting a lot of emails through at the moment with questions as well, which I'm trying to get to. I promise if I don't get back to you tonight, I will in the next day. I'll pass back to you, Steve, see if you've managed to catch up on some questions. But like I said before, if we don't get through all of the questions today, there are a lot of people attending. Please email me questions directly, and we will get a course advisor to either contact you on the phone, if you prefer that, so provide your phone number, or by email to help you as much as possible.
Okay, what I'm going to do is I'm going to answer the last 2 or 3 questions here because I know a lot of people want to run. What I'm going to do is we're going to copy all these questions. I'm going to ask Shanae to, if she doesn't mind copying all these questions tomorrow when she's got a moment, or Carol. Maybe Carol, you can copy the questions out of here, and then we'll provide you with an email to all the guys that attended with answers to these questions. But effectively, I'm just going to answer a few here. Just hang on. Let me just answer some of the last few questions because there's some really interesting questions here. And the good thing is you guys must always ask questions, never accept anyone giving you stuff without evidence. Okay, here's an interesting one here. JBT Junior Live Com. According to the diagram, professional engineering recognition will only be achieved through Professionals Australia only if the BSc and Master courses are under Washington Accord plus EA accreditation. So here's a question. What is the EIT plan for getting EA accreditation and then go through PE recognition? Okay. We are actually going through the application at the moment. So the master degree, for example, we've got one of our master degrees going through. It's been going through the system for the last 12 months, and we're getting close to finalizing. They've listed 17 points, which we had to comply with. We've gone through those. We've complied with them. Engineers Australia want to make sure they're not fraudulent, useless programs. They want to make sure that people leave with good job outcomes. And that's why Engineers Australia are very concerned about making sure that they live up to the right standard because their name will be on it. So we believe we will get that through the system because they've come back with the comments. This is what needs to be done, and we've dealt with those. So I think we've got a good chance. Again, it's a probability factor. Okay, next question. Should EA make residential units compulsory? Would EIT offer? Yeah, well, look, we're running residential units anyway because we've got school leavers that will be attending these courses, and we have to make residential units compulsory for them because they know nothing about engineering. They probably don't, as I said, probably never worked with an oscilloscope or probably not even a hammer or a screwdriver. So we have to make sure that they actually have some physical experience because if they don't, they'll be unemployable. So that's part of our mission. We will be offering that. But we believe that if you are a highly experienced technician, your residential component should be fairly minimal or non-existent. So, I suppose you believe in, let me just go to the last one here. What happens if you fail? I'm just trying to answer these questions. Okay, there's a question here. Mechanical Engineering BSc brochure, page 7 shows fundamentals of electronics. Why not fundamentals of mechanical engineering or something similar? Well, you'll find in the mechanical engineering, there's the fundamentals of mechanical engineering. The units are fundamentals. We built that in. The electronics is just that we believe that electronics is pervasive, and we think that things like data acquisition, ability to acquire data is prevalent right throughout engineering. So we've made that a core unit. The guys that are probably the most agitated by that would be the civil engineering guys because they say, well, electronics is a bit far beyond me, but even on a bridge, you need strain gauges to monitor stresses and strains. So we think it's a worthwhile thing to put in. Okay, next question. What if you fail a unit module, can you catch up as you continue? Yes. What happens is that you would lose probably, if you fail a unit, you have to redo it, and you would then incur a small cost, but you would then find there will be another cohort coming up behind you, another group. And we have groups starting every 6 months, so you wouldn't lose more than 6 months. But you probably could continue with the other units if there's no prerequisites for them. Depends which units it is. Okay, let's go to the next question. If one has a BTech South Africa and wants to convert to BSc Engineering, blah, blah, blah. A BTech is a qualification in South Africa, which is a 3-year program. You'll probably find that you would get quite a lot of credit for the BSc. The BTech, as I understand it, in South Africa has been discontinued because of a poor reputation, which I think depends on which university or which college you've gone to, but I think it's been discontinued or been restructured quite significantly. So you would get significant credit for the BSc. I would argue that if your BTech is very similar to the BSc, you should not consider the BSc, go on and do their master's degree because you don't want to waste time redoing a degree again if it's very similar. You're just wasting money and time, probably money as well as an issue. Again, we can answer that question in more detail. Okay, here's another question. Blair Electrical, there is a festival season break. Yeah, okay, Shauna's answered that. Asked that question, would need a direct converter. Yeah, okay. So Shauna has been answering some of these questions here. Thank you very much, Shauna, for helping me. I'm sorry to pull you out of your home routine to help here. BTEC and BSc are on the same level as NQF, but BSc has more points than the BTEC. Yeah, that's right. Thank you very much. Absolutely right. You may find that you find you get a lot of credit for the BSc, but I would argue that if the BTEC is almost the same as the BSc, don't waste your money and time on doing a BSc. Just go and do a master's degree either through us or through another university and get your professional recognition that way. Okay, I think I'm almost at the end of this. Here, Shana has answered a lot of the questions. What we'll do, thank you so much for your questions, and it's just fantastic being so overwhelmed with so many incredible proactive people here. I just want to thank you very much for attending. We will answer all these questions on an email, so watch for the email, and we'll be redoing this session again in 2 weeks' time. I think Shana will let everyone know if there's any other questions. So I'm just very grateful for you attending. Your career is very important to us. I know as the cynics, and I'm a cynic as well, would say, well, that's Steve just talking, but we are genuinely committed to helping you with your career. And we believe we've got a remarkable, well, a reasonably remarkable opportunity to offer a degree which has got quality, not necessarily because of EIT, but because we've got this incredibly experienced instructors, and we've got a good track record of 25 years worth of materials. If you've done the advanced diploma at the EITs, that's 3.5 or 4 years for the BSc. It's 3.5 if it's a BIA. If it's a advanced diploma in electrical engineering and you're doing a BSc electrical engineering, it'll be a 4-year BSc. Okay, I just want to say thank you very much. We will take all your comments. We're going to post them in and send a little email out in the next few days. Carol or Shane will grab them all together and we'll give you a comprehensive answer. But thank you very, very much for attending. I'm very grateful. Thanks for such a great presentation. And thank you for those awkward questions. You really put me on the spot. You had me writhing in my seat for a few moments. But at the end of the day, it's your career. You need to ask the questions and don't take nonsense from anyone, including EIT and Steve Mackay. So thank you very much, Carol and Shane, for attending. I really appreciate it. And I'll pass the microphone back to dear Carol in hot London from chilly Western Australia. Thanks. Bye.
Thank you, Steve. And yes, it was good to see you being put on the spot for once. Well done to everybody for their questions. And as Shane said, we will get back to you and answer all of the questions that you've posted. If Steve didn't get round to answering them, then Shane will make sure that if she doesn't advise you, one of the other course advisors will be in contact with you. And we will send you a recording of this session within the next 2 weeks. Thank you very much for joining us today. Thank you, Steve. Thank you, Shane. And we look forward to working with you in the future. Thank you.
Thanks for that, Carol. Thanks, Steve. We're dismissed, Steve. Enjoy. Carol, thank you so much for assisting there. I know you had some internet issues, so I really appreciate that. I will stop the recording now.